So, right. Hi everyone, welcome back to Geeks for Geeks practice. So, today we will discuss the problem of the day for yesterday, that is kth element in a matrix, and this was a medium level problem. I'll just wait for some time for others to join and then we'll start. Uh, all those of you who have joined the session, please like the video and please give a +1 in the chat so that I know that my voice is perfectly audible to all of you and my screen is visible as well. And then I'll wait for a couple of minutes more for others to join, and after that immediately we'll begin. Okay, so I am just waiting for others to join. This is a very interesting problem, I should say, because this problem has been asked in several companies, and this is a pretty important problem because it can be solved using various ways. So it has it can be solved using one algorithm and one data structure. So both of them are unique approaches in themselves, given the problem statement, right? So this is why this will be an interesting problem for us to discuss. So I'll just wait for some time for others to join. Meanwhile, all those of you who have joined, please give a +1 in the chat so that I know that everything is working fine, and then I'll begin with the problem. So just to give you a little bit brief about this problem, the problem name is kth element in the matrix. So after reading the problem statement, you are very much clear that you have to find the kth element of the matrix. And apart from this, one more thing, you know that you have been given a matrix, that is also perfectly fine, but one thing that I want to highlight it is that this problem has been asked in companies like Amazon, Acolyte and others as well, right? You can see that the topic tags are heap and matrix. So you can see that this problem has 23,000 plus submissions. So this is a medium level problem, quite an interesting and important one. So all those of you who have joined the live stream, please like the video and give a +1 or a thumbs up in the chat as well, so that I can begin with the problem ahead. Okay, right? So just to explain the problem says that you have been given a matrix of n cross n. So the dimensions are n cross n, and every row and column, so every row and column is sorted in non-decreasing order. We will come to this, like what is a non-decreasing order. So basically you can say in ascending order, right? I'll come to this when we'll discuss the test cases. And you have to find the kth smallest element in the matrix. Okay, so this is what you have to find. So consider that you have been given this matrix. Let's say you have been given this matrix. Okay, so just let me just copy this matrix first. Okay, I'll copy it. So now I've copied it, right? Just let me erase this much part. So this is the question, first test case. Okay, so Chandu MJ +1. Hi Chandu. So what this problem says is, let me first draw this matrix. So the matrix looks like this. Let's say this is the first case, 16, 28, then we have 60, then we have 64. Below this we have 22, we have 41, we have 63, then we have 91, and the next row looks like this: 27, 50, 87, 93, and then after this 36, then we have 78, 87 and 94. So important thing about this matrix is it is a every row and every column is sorted. Okay, every row and every column is non-decreasing. Okay, every row and every column is non-decreasing. So I can see a lot of people are watching, so please give a +1 in the comment so that I know that everything is fine. Okay, so that I can start discussing the test cases properly, because I'm still waiting for your response so that you don't miss the essential important part of the questions, right? So if you will see from left to right, then you have 16, 28, 60, 64. So this is ascending order, or you can say non-decreasing. Okay, 22, 41, 63, 91. You can see that for this as well, it is in sorted manner, right? Then 27, 50, 87 and 93, this is also sorted. Okay, then 36, 78, 87 and 94. This is also sorted. So hi Bhaumik, hi. Then if you will if you will see from top to down, right, so you can see that for each particular row, like for each particular column, sorry, for each column you can see 16, 22, 27, 36. This is also sorted. 28, 41, 50, 78. This is also sorted. Then this is also sorted, and this is also sorted, right? So everything is sorted. So you can see that everything is either either ascending, or it is at least non-decreasing. If the elements are same, then it is non-decreasing. Okay, so if I had to find k is equal to 3, okay, so if I had to find the third smallest element, so what is the third smallest element in this array? Can anyone tell me, in this matrix, which is the third smallest element? Can anyone tell me from the chat? So the third smallest element is nothing but 27, right? The third smallest element is nothing but 27. So in the end you have to return this 27, right? The kth smallest element, that is the third smallest element, here it is 27, right? So this is how you have to this is what you have to do. So can someone has anyone solved this question? All of you who have joined this live stream, I just wanted to know if anyone has solved this question, or can someone give me some hint like how we can solve this question, so that like you can give me a hint. If you have solved this question, you can give me a hint, right? Or if you have any approach, so you can tell us about in the comments, so that we can discuss upon it. Or if you had any difficulty while solving this problem, so you can just mention that in the comments, so that we can also take up. So how can we do this? Like, anyone has any idea? You have to find the kth smallest element in the matrix. Okay, you have to find the kth smallest element in this matrix, right? You have to do this. How we can do this? So first, okay, so you can repeat the question. I just joined a little bit late. Yes, I can repeat the question. So what it says is, what this question says is, all the rows and all the columns are sorted. Like if you see 16, then 28, then for this particular row 16, 28, 60, 64, then for this particular row 22, 41, 63, 91. So all the rows are sorted and all the columns are sorted as well. So you can, if you look at the first column, 16, 22, 27, 36, so this is also sorted, right? So all these rows and columns are sorted, right? So this is what has been given. They are sorted, or you can say they are in either in ascending order or in non-decreasing order. Okay, so this is what the problem says. So this is the specialty that has been given in this matrix. Apart from this, what you have to do is, you have to find the kth. You have been given this matrix, and you have to return the kth smallest element of this matrix. So let's suppose that for this, if the k was equal to 3, then the kth smallest, or the third smallest number, would have been 27, right? So this is what you have to do. Is everything up till now clear to everyone? If up till now everything is clear, then please give a +1 in the chat, so that we can move ahead with the question. Okay, so moving on, let's move on. So how we can solve this problem? First of all, if you will see, what I can do is, first of all, brute force. Okay, first of all, brute force. So what I can do is, I can apply a brute force. What I can do is, I can insert all the elements. I can declare a vector. Okay, I can declare an integer vector v. I can insert all the elements of this matrix into the vector, and then I can sort the vector. Which will take a time complexity of order of n log n. It will take a time complexity of order of n log n, and in the end, what it will do is, it will give the k minus 1th element of that particular sorted array. I can basically sort the vector. So sort v dot begin, comma v dot end. This is what I can do. V dot end. This is like, I can just sort it simply. Nothing much. I can just apply the sort function, and then if I'll return I can simply return the k minus 1th indexed element of the vector, and I will get the kth smallest answer, right? Kth smallest element, that I can simply return it. Is this part clear to all of you? So for this, you will take a time complexity of n log n, and you will also take a, yeah, right, k minus 1, perfect. Abhishek Dubey, perfect. Apart from this, what will be the space complexity? So time complexity will be order of n log n, but what will be the space complexity? So the like time complexity will not be n log n, okay? So this is a mistake. N square log n square, okay? So this will be the time complexity, because in this I am trying to insert all the elements. There are basically n square elements, right? So that is why the all the elements, if I'll push it into my answer, so that is why this will not work for me, okay? And the space complexity will be order of n square, since I will try to store all the elements, right? So this is the brute force, but it is not at all optimal. It is not at all optimal. Can we use max heap logic here? Yes, we can use max heap or min heap, okay? Right, perfect, perfect, Abhishek Dubey, your answer is correct. Now next up, moving on, what I can do is, what is the second approach? So second approach has been told by this guy. So in the comments, someone has suggested that can we use a max heap or a min heap, okay? Can we use a max heap or a min heap? So you can use both. You can do this question using max heap as well as min heap. But like what will you prefer? Will you prefer doing this using a max heap or a min heap? So if you remember, in normal, there is a normal question, kth smallest element, okay? Kth smallest element in an array, okay? The question can name can vary a little bit depending on the platforms, but this is the question, kth smallest element or kth largest element is also one question. So how do you do this question? Okay, how do you do the kth smallest element question using a heap? So for that you use a max heap, right? Min heap you can also use, but here we will try to use the max heap. The reason is I will tell you in some time, but we can use a max heap. That is, in C we are going for smallest to max, yeah, right? So the concept is that if you have to find the kth smallest, there is a concept, or you can say a trick or basic standard that we apply for simplicity. If you have to find the kth smallest, then you use a max heap, okay? Then you can use a max heap. And if you have to find the kth largest, so you can do what? You can use a min heap, okay? So this is why using a max heap will be much more optimal, okay? Now how we can do this? So since I have to use a max heap, so what, first of all, if I am using C++, let's say I use C++ for my solutions. You can use Java as well. You will also find a max heap there as well. So what I'll do is, so what I can do is, from here I can declare a max heap, okay? I can declare a max heap. Let's say I can declare a max heap. Let's say I declare a max heap priority underscore q int pq, okay? Let's say I declare a max heap. Then what will be the approach for this? Like Archishman, can you suggest like how we can do this? If you can suggest, then it will be much more interactive. I can see a lot of people are watching, so please like the video so that it reaches to as many people as possible. Also please give a +1 if up till now whatever I have told, if it is clear, then please give a +1 so that I can move ahead, okay? So I am using a max heap, okay? So this is a max heap. How we can do this? So let's consider a smaller test case, or let's see what is the other test case that has been given to us. So let's say that we only have this test case, right? Let's try and see the test case that has been given to us from there only, the initial test case that has been given to us. Let's try and check this test case itself. Like how we can do this? How we can do this? Someone will say that let's insert all the elements into the priority queue, right? Into the max heap. Someone will say that let's insert all the elements into the max heap, and then we can say we can pop out and we can get the kth, okay? We can keep a counter, but that will not be optimal, okay? Because if you are inserting all the elements, then it will take time to heapify as well. It will take time to show itself as a max heap as well. So this will take a lot of computations. So what you can do is, since you have to find the every time you just keep a track. What we generally do in such questions, finding the kth smallest element in a normal array, or the case here is kth smallest element in a matrix. So what we basically do here is we just do one thing. We just keep a check that the size of the max heap should be equal to k only. Okay, every time what you try and see is every time you push an element, so you check that if the max heap size, if the size of the max heap, or if the number of elements in the max heap, if they are greater than k, so you just pop them out. Okay, so what I am trying to do is what I am trying to say is like you just keep on pushing the elements one by one. You just start iterating. So let's say first of all I'll push 16, right? I push 16 and my k is equal to 3. Okay, k is equal to 3. Let me just draw it in a smaller fashion. So I have pushed initially 16. Okay, initially I have pushed 16 in this. After pushing 16, what I can do is I can push the next element. So let's say I push 28 as well. So I have 28. 16 will be 16 will not be at the top. 28 will be at the top now. Okay, 28 then 16. Then I'll push the next element. After I push the next element, what will the heap look like? So 60 will be at the top and 16 and 28 will remain, but the top element of this max heap will be 60 because it is the maximum. Now what I will do is I'll insert 64 into it. Okay, I will insert 64. So 64 will be at the top and I have other elements 60, 16 and 28, right? So once I have these elements, so I'll check what is the size. So the size of the max heap now is 4. Okay, size of the max heap is 4 and this size is greater than k, right? So the moment I see that the size is 4, so what I'll do is I'll pop out this particular element. Okay, I'll pop this particular top from the max heap, and then what I'll get is 60, then 16, then 28. Okay, so now the size is greater less equal to k of my priority queue, now of my max heap. Okay, now what I can do is I can insert the next element from the element from this, the second row, that is 22. Now I'll be inserting 22. The top element will be still nothing but 60. Then we have 16, 28 and 20, right? So the internal elements will be in form of a tree, but we know that for a max heap it is for sure that that the top element will be 60. That is the maximum element present. Okay, now you can see that the size is 4. So I'll simply pop out, I will simply pop what, 60, that is top of this stack. Then what are the elements that I have now? What are the elements that I have in my stack now? So the elements that I have in my stack are nothing but I have then what I'll do is after I pop out, so I have 16, 28 and 20, right? So 28 will be at the top, so you can just keep it at the top. Since now 28 is at the top, so what I'll do is I will now try and insert this element. Okay, 41. Once I insert 41, so 41 will be at the top and other elements are 16, 28 and 20. So you can see that again the size of my heap is greater. So I'll pop this 41 out, the top out, and after that I'll insert this 63. Once I insert 63, so 63 will again go out because once I insert 63, the elements will be, the size will be greater than 4 again. So I'll pop this out. Then after that I can similarly push 91. Once I push 91 into my max heap, so 91 will be at the top and I'll remove 91 as well. So again the size will be 3. Again I'll insert the next element and it will be 27. So when I insert 27, so 28 will be at the top and the size will be greater than k, right? So in this case I will pop out 28 as well. After this, similarly I'll keep on doing this. So what are the elements that will be present at the end? Can someone tell me what similarly at the end, once I keep all the elements into my priority queue, keeping in mind that my priority queue should not exceed a size of k at a particular point of time. So how we will do this, like what will be the approach for this? So what will be in the end, what will happen is in the end you will notice that there will be 3 elements only left. Okay, in the end my max heap will contain only 3 elements, right? And at the top of my, in the end my size of the max heap will be 3 because only 3 elements will be there, right? Okay, yeah, right. So in the end I'll have a max heap of size this, and what will be the element at the top? So at the top you will notice that at the top I will have 27, right? At the top I will have 27 in my max heap, and other elements that I'll be having is 16 and 22. So at the top I have 27, and once this is done, once this gets done, so you can see at the top I have 27 in my max heap and the size is 3, right? So if I'll check for my top, so if I'll check pq.top or peak in case of Java, depends on the language. So if I'll check that, so the top element in the end will be the kth smallest element. Okay, why is this so? The reason for this is because we are using a max heap. Okay, since we are using a max heap, so the property of the max heap is that every time you will pop out an element, so does this reduce the chance that does this mean that every time your size of the max heap it gets greater than k, so you pop out an element, but does that mean that you might end up popping out the kth smallest element of the complete matrix? No, that will not happen, because since this is a max heap, so always the maximum elements will be at the top, so the minimum elements, the smaller elements, will remain down. Okay, will remain inside the max heap itself, and the top will be pointing to the largest element currently present in the max heap. So that is why at the end, when you have only 3 elements left, so the element which will be at the top, that will be the kth smallest element of this priority queue or this max heap. Is this much part clear to everyone? I can see a lot of people are live watching, and explanation is also I think decent enough, so please consider giving a like to the video, and please give a +1 in the chat if this explanation is clear to all of you. What will be the space complexity? So the space, since we are not inserting more than k elements, so at a particular point of time, so the space complexity will be order of k, right? And what will be the time complexity? Can someone in the comments tell me? If I'll use a max heap, then what will be the time complexity? Can someone in the comments just tell me what will be the time complexity? What will be the time complexity? What will be the time complexity for this solution? The space complexity will be order of k. What will be the time complexity? Anyone can tell me? I can tell you, but I want answers from all of you. Okay, so what will be the time complexity? Can someone tell me? Since we are using a priority queue, what will be the time complexity? So it will be, okay, Abhishek Dubey and that switch, all of you are giving a +1, so thanks. So I think that you have understood this much part perfectly. Okay, so what I'm saying is the time complexity will be nothing but order of k log n. Okay, what will be the time complexity? Can someone tell me? What will be the time complexity? Still, like, I am waiting for 30 seconds more to listen the time complexity from all of you. Like, what will be the time complexity? What can be the time complexity? Not n square, Abhishek, not n square. No, n square will not be correct. What will be the time complexity? Notice that every time you are pushing elements, right? You are pushing all the n elements into the queue. So since you are pushing, every time you put an element into the heap, so it takes order of log k time for heapify operation, right? This is heapify, or for getting the largest element or the topmost element at the top, or the maximum element at the top. For getting this, you have log k. And another thing, you will use n. Okay, you will use a n because you are also taking a time of n. Yeah, right. Okay, so what happens is, like, for this case, what will happen? Yes, I am only talking about the data structure. I am only talking about the heap process. Okay, so log k, because heapify, because every time you have not more than k or k plus 1 elements, because whenever you have k plus 1 element, so you pop out the topmost element, right? So every time for heapify process, or for getting the maximum element at the top of the max heap, it takes a complexity of log k. And since you are doing it for all the elements of a particular row at a time, right? At a particular time, so that is why this can be the time complexity. Okay, now moving on, is there any other approach? So the third approach that I want to discuss, there is a third approach. Okay, before moving on, so I'll show you my code. Like, let's look at the code. So what I've done is basically every time I'll keep on pushing, I'll declare a max heap. Okay, I have declared a max heap, and once I have done that, let me show you, just zooming in a little bit. What I've done is I've basically declared a max heap. Okay, and this is a max heap in C++. You can declare a max heap in Java as well. Okay, Then what I've done is every time, like I am putting all the elements into the one by one, I'm putting the elements into my max heap, and I'll check if my size of the priority queue is greater than k. That is, if the size of my max heap anytime is exceeds the k, then I'll pop that out, and at the end, because if you will insert, okay, so this guy is saying that why can't we insert all the elements into the set. So someone is saying that why can't we insert, Ritik is saying that why can't we insert all the elements into the set. So for a set, it will take n square. If you will insert all elements, so it will take this much time complexity, right? You have n square elements, right? You have n square elements, n square total number of elements, and for sorting all those elements in the set, it will take this much time. Okay, the complete process will take, if you add n elements, then it takes n log n. Okay, so if you have this much elements, then this will be the time complexity, and order of n square will be the space complexity. Okay, so this is why using a set will not be optimal here. That is why we are trying to use a priority queue. Okay, is this much part clear to this, Ritik? I hope that your doubt is clear that why we are not using this. So this is what I am saying. Let me submit this. After this, we'll look at the binary search approach, like how we can do this using binary search as well. So let's see. You can see that my code is not taking much time, 0.1 second out of the 1.2 seconds. Okay, so now this code is done. So if this code is clear for you, then please give a +1 in the chat. If the heap process, if the process from the heap part, max heap, so approaching the solution using a max heap, if this part is clear to all of you, then please give a +1 in the chat, and like the video as well, so that I know that I can move ahead. Okay, shall I move ahead with the third approach? Like, what will be the third approach? So in the third approach, what I can do is I can use a binary search approach, right? Because every time it said, okay, +1. Ritik is giving a +1. Okay, so what about others? Have others understood it? Please like the video and give a +1, because only then I will be able to move ahead, because I want to know that everything up till now, whatever I have told, is clear. Okay, so Ron is saying +1, Abhishek Dubey is saying yes. So I think that I can move ahead. So now moving on, like you can notice one thing, it was given in the question that every, so that switch is also giving a +1. Oh, thanks. So every row and every column is sorted. Okay, every row and every column is sorted, right? This is something that we need to discuss upon. Let's look at this matrix. Okay, let's forget all these things. Let's just forget all these things, right? And let's look at this. If you look at this matrix, then you can easily observe that all the row, for this particular row, it is sorted, right? It is sorted. For this row, it is also sorted. 22, 41, 63, 91. You take any row, it is sorted or it is non-decreasing, right? And for any column as well, any particular column, you can notice this, that for any particular column as well, you can easily check, you can easily verify that all the elements are what? All the elements are present in a non-decreasing or ascending order, right? So every row and every column is sorted. This is one of the biggest hint that the question has given to us. Okay, now why I am saying this? So why am I emphasizing on this point? Because I said that in the third approach I can apply a binary search. What is the condition that when you apply a binary search? What is the condition? I want to know in the comments from all of you, what is the condition when we apply a binary search? When do we apply a binary search? When do we apply a binary search? I want to know in the comments. What is the criteria for applying binary search? What is the prerequisite for applying a binary search? Can anyone tell me in the comments? Just quickly, just within 30 seconds or 15 seconds. I want a reply. Then when do we apply a binary search? Sorted, right? Chirag is saying sorted. So whenever you have this thing, that is whenever the data set that has been given to you, it is sorted. In this case, every row and every column is sorted, right? That is why I can apply a binary search. Right? this is clear to, I hope that this is clear to all of you, why to apply a binary search. Now how can I apply a binary search? Notice that for binary search you need a low. So what will be the low for this? What can be the low for this? I will apply a binary search. What I'm saying is I will apply a binary search on the range. Okay, on the range. I am saying that let's apply a binary search on the range, not on the indexes, on the range, on the numbers, not on the indexes, right? What I'm saying is let's apply a binary search on the range itself. So what is, if I'll apply a binary search for the range, what will be my lowest element? So my lowest element will be nothing but the first element of the matrix, that is mat of 0 0, which will be nothing but, which will be equal to 16, right? This has been given to me. Okay, and what will be the high? What will be the high? Can someone tell me in the comments what will be the high for this question, for this case, for this test case? So the high will be nothing but matrix of mat at the index n-1, right? At the n-1, considering a zero based indexing, so it will be nothing but 94, right? This is the maximum minimum element of the range, and this is the maximum element of the range, right? If this much part is clear, now what you do, you try and check for the mid. So what will be the mid? In this case? What you do in binary search, you check that while low is less than high, then after that what you do is you try to calculate the mid. What will be the mid? Mid is nothing but low plus high divided by 2, right? So what will be my mid? Can someone tell me in the comments what will be my mid? What will be the mid for this case? Can someone tell me about that? What will be the mid? What will be the mid for this case? For this case, first of all, I'm saying let me just change the color of the pen. Okay, so I'm saying that my low is 16 and my high currently is what? My high is 94. So what will be my mid? What will be the value for the mid? I want the answer. What will the value? Value will be low plus high divided by 2, right? So it will be what? 16 plus 94, which will give me what? It will give me 110, right? It will give me 110 because adding 16 plus 94 gives 110. When I divide it by 2, I simply get a 55, right? I simply get a 55. Perfect. Okay. What can I do with this? What can I do with this mid? What can I do with this mid? Can someone suggest me in the comments like what we can do with this mid? Can someone in the comments just suggest me what we can do with this mid? For this particular mid, what we can do? If I have the, suppose that I have the mid, right? I have the mid. Now what I can do? What is the thing that I can do? Can someone suggest like what we can do further? Once you have the mid, what we can do ahead? Can you think about it? I can definitely tell you the solution, but after you get the mid, what is the intuition? What is something that you can do? What can you do? If you, let's suppose that you get the mid, right? So after that, what you can do? So you will do nothing. You will try to check once you get the mid. Okay, just let me just undo things. Okay, so check which element we have to find. No, we will not do this. Okay, compare with mid, right? This is what I wanted to know. So what we will do is we have this. Okay, we have this 55. What I will do is I will check I will count the total number of elements which are lesser than this 55, right? I can, after this, once I get this mid, I'll find the number of elements which are lesser than this particular value mid. So what I'll do is, for this row, what are the elements? For the first row, what are the total number of elements which are lesser than 55? So 2. Okay, for the second row, what are the number of elements? So for the second row, what are the number of elements in the matrix? For the second one, it is nothing but 2 as well, right? Then for the third one, you can see that 2 again. For the fourth one, you have 1. So what is the total that you get? Total you get 7. What is the value of k? K has been given to us as 3. So it says that 55, if I have this mid as 55, then I can easily say, when I have this mid as 55, then it simply means I cannot stop this bot. I don't know where it has come from. Okay, so once I have this mid element, so for this with this mid element, what I can do is this mid element, if it is if suppose my number was 55, right? If suppose my number was 55, then there are 7 elements which are lesser than this. So if there are 7 elements which are lesser than this, so this will be my 8th element, right? But I want k is equal to 3. I want the third smallest element, and this element is greater than 7 elements, right? So this means what should I do? Should I reduce? I will be reducing my search space in the binary search. So what should I do? Should I update my mid? Should I update my low, or should I update my high? Should I decrease my search space? Should I move to the smaller values, or should I move to the higher values? Right. So I what I will do is what can I do? What will I do in this case? So in this case, since I am getting this, so what will I do? Can someone tell me what will I do after this? So since what is happening, I'll check if the number of smaller elements, if they are greater than k, right? So that means that I need to update my low. Low will be what? Low will be, no, I don't need to update my mid. I don't need to update my low. If the smaller elements are greater than k, that means that I need to shrink my search space in such a way that my low will remain the same, but my high will be now mid. Okay, my high will be mid. Otherwise, if I am getting, suppose that I am getting the number for, I get a particular mid, and for that particular mid, the counter of the number of smaller elements than it are lesser equal to k. Okay, so in this case, lesser than k, if it will be this case, then what will happen? In that case also, it will create a problem. It will be creating a problem, because in that case I will not be able to get the kth element, right? So in this case, what I'll do is I'll move my low to mid plus 1. Okay, I'll move my low to mid plus 1, because now I need to increase my count. Okay, I need to look for a bigger element. So that is why now my search space will be from mid plus 1 to high. Okay, is this much part clear to all of you? Is this much part clear to all of you? I just wanted a plus 1 if this much part is clear to all of you. Okay, I can see a lot of people are watching, so please like the video, and please give a plus 1 if this much part is clear to all of you. Okay, what I'm saying is you just keep a count. Okay, and if the count of the smaller elements compared to the mid for each row, if the total summation count for every row, the total rows, for that particular mid, if the count. Okay, how to find the smaller? So there is a function in C++, there is a function named as lower bound. Okay, there is a function named as lower bound. So using that function you can find it. Let me also show you the code part for this. Like I'll show you the code. Let's see the code so that things are much more clear. What I can do is, okay, this is the code. So what I'll do is, first of all, I'll initialize my low. What will be my low? Low will be nothing but the first element, the smallest element. High will be what? The last element, that is element at the index n-1, right? n-1, the element if the array matrix is nothing but sorted in row wise and column wise fashion, right? And if I find that the kth smallest number, if they want the kth smallest number such that it is the last element, if they say that the kth smallest element is nothing but n cross n, that is n square, that is the last, that if they want the largest element, right? If they are saying that that they want n squareth element, right? So if they want the last element, then you can simply return the high. Otherwise, what you can do is you can apply binary search, and in binary search low will be less than high. So if this is my search space, if my search space was from 0 to n, right? If in binary search, if my search space is usually from 0 to n, then in that case my time complexity, what is my time? So I take log n time for that, right? I take log n time because I keep on dividing my search space to half. So that is why it will be nothing but log of this binary search will run how many times? This while loop, it will run max minus min. Okay, it will run high minus low number of times. Okay, high minus low. Why? Because the difference between the maximum and the minimum element, it will run this much number of times. Then what I'll do is I'll simply find my mid, and I will keep a counter, keep a small variable named as counter to find the number of elements in the matrix which are lesser than this value. Okay, this is what I'll do. This is what I'll do. Then after that what I'll do is, after that, for every row, notice that I'll do this for every row. I'm not doing this through the matrix. I'm doing this for every row of the matrix. I will count the number of elements which are smaller than my mid. And how I can do that? I can simply apply a lower bound function. And what I can do for the ith row, okay, for the ith row, I can do this. Okay, I can simply apply for the ith row, and I can keep on tracking the total sum using this smaller variable, smaller plus equal to, which will give me the number of elements which are smaller than the particular element that I am at. So I'll simply apply a lower bound of mat I plus 1, I plus n, comma mid. Okay, this is how you apply a lower bound. Again, I am assuming that you know what is a lower bound. Even if you don't know, so just consider that it is used to find it can be used to find the number of elements which are smaller than a particular value. In this case, our value is mid. Okay, after that what I'll do, what you do is you subtract that particular first index, okay, first element. So this is what you do using lower bound. So after this, your smaller will contain the number of elements which are smaller than the current mid. Okay, the smaller will contain the number of elements smaller than current mid in the matrix. Okay, this is what it will be. Then after that, if the number of smaller elements, okay, let me just uncomment it. Let me just remove this comment so that you can read it perfectly. If the number of smaller elements is less than k, okay, if the number of smaller elements is less than k, so what you will do is the value that we will be looking for will be higher than the mid. Okay, if the number of smaller elements, if the number of elements which are smaller than the current mid, if it is lesser than k, that means that you need to move your search space from mid plus 1 to high, right? So that is why you will need to update your low. Okay, you will need to update your low. So low will not be nothing but mid plus 1. Otherwise, there can be a situation that smaller is greater equal to the number of elements which are smaller than the current mid. If it is greater equal to k, so that means that your mid is higher, and you, for coming to the kth element, you need to move your search space from low to mid. Okay, so that is why, since you need to decrease your mid, so that is why you will be decreasing your high. So your high will become nothing but high is equal to mid. Okay, and in the end you can simply return low minus 1. If you will return low minus 1, then that will simply give you the answer. Okay, that the low minus 1 will be nothing but your smallest kth smallest element. Okay, so just if like up till now whatever I have told you, is this much part clear to all of you? I just wanted to know, I just want to confirm up till now whatever I have whatever we have read. So is this much part, like binary search part, is clear to all of you, like how we are doing a binary search? Just give a +1 and like the video. Please like the video. I can see a lot of people are watching. Like, first of all, we discussed a brute force approach, right? We discussed a brute force approach. Then after that, we discussed an approach using the max heap. Okay, using the max heap, right? After this, in the third approach, we discussed a binary search approach. Okay, we discussed a binary search approach. Why could we do a binary search? The reason why we could do a binary search was because I can apply a binary search simply because of the reason that it has been said to me, it has been given to me that every column and every row is sorted, right? So that is why I can apply a binary search. Once I apply a binary search, so you can see that since I am applying binary search for every row, right? So what will be the time complexity for the binary search? Usually it is n log n, but in this case it will be a little different. Why different? So since you are doing binary search, how many times your while loop is running? While low is less than high, how many times it will be running? So it will be running for log of max minus min. Okay, max minus min. Okay, what is max? Max is the highest element and min is the lowest element, right? This is for what? This is for this time complexity is for the loop which will be running lowest less than high. Okay, so this loop will be taking this much time. Now next up what will be the other time complexity? So since you are doing this for n rows, okay, since you are doing this for n rows, and in the ith row you are applying a lower bound function, so it is in the ith row there are n elements, right? So since you are applying a binary search on the particular ith row that is having n elements, okay, for the ith row, for finding the elements lesser than current mid in the ith row, okay, in the ith row. So that is why log of m into m log of basically max minus min for the while loop, for the number of times that your binary search will be up, you will be doing this binary search, that is finding your mid. Then once you find your mid, for every row, okay, for all rows you will take, since you are trying to calculate all the elements in the all the rows, the sum of elements which are smaller in the complete matrix, and you are doing this in row wise fashion. So you will run a loop for all the n rows, and in each row you will take log n time complexity to find the number of elements which are lesser than the current mid, okay, and you are taking a sum of that. So this is for lower bound function, okay, lower bound function, right? So lower bound function will be taking log n time. If you can customize, you can write a binary search, smaller binary search for that as well. So this is why the time complexity will be log of max minus min into n into log n, right? For this code that I have written, okay, for this code that I have written. Now let me just submit it, okay, let me just submit it and show you that this works. Let's just see that does this work or not, okay. Let's just see that does it work. Yes, it works, okay. This is the correct submission, okay. You can see that my submission for binary search has got accepted, okay. So this is what I'm doing. Let me show you my code once again. What I'm doing is one second. What I'm doing is basically I'm doing nothing. First of all, I'm taking my low will be what? Smallest element. High will be what? Highest element. I'm doing a binary search on the range, and if the kth element is nothing but the last element, then I can simply return the high. Otherwise I'll apply binary search, and for this it will take order of log of max minus min, right? Max minus min, because that is the total number of times my while loop will be generating, okay. If it was from 0, if my low was 0 and high was n, so it would have been order of log n minus 0, okay. So it would have been log n, but here it is log of max minus min, okay. That is why here the min is not 0, which is why it is log of max minus min. It is very similar to order of log n, okay, but here the values are not n and 0, it is max and min, okay. Now you will calculate your mid, and you will have a variable to store the number of smaller elements in all the rows or in the complete matrix. For each row you will be iterating, and you will be calculating the sum, and you will apply a lower bound function to calculate the number of elements which are lesser than the current mid. And if the number of elements which are smaller than the current mid, if it is lesser than k, so that means that the kth element that you are finding, for that you have to change your search space from low to high to mid plus 1 to high, because you need the mid to increase. Since you want the mid to increase, so you will change your lower bound, okay. You will change your low from low to mid plus 1, right? And if that is not the case, suppose that the number of elements which are smaller than the current mid, if it is greater than k, greater equal to k, so that will mean that you need to update your high, and high will be what? Mid, okay. So now the search for this else part, the search space will be from where? The search space will be from 0 to from low to mid, okay. And in the end you can simply return your low minus 1. This is how you will be doing a binary search. Is this code clear to all of you? I just want to know in the comments, is the approach clear to all of you? Is the approach clear to all of you? All the three approaches are clear to all of you, okay. Is the approach clear to all of you? Is the approach, all the three approaches, first approach was brute force, second was using max heap, the third approach was using binary search. All the three approaches are clear to you? All of you are clear with the approach? Just please give a +1 in the comments and like the video. I can see a lot of people are watching. Please like the video if the approach is clear and give a +1 or write clear in the chat so that I know. So Gopi, it is clear. Ritik official, it is also clear, right? I can see a lot of people are watching. All those who have not liked the video, please like the video. Okay. So this was the problem, and these were the 3 approaches. First, I discussed using brute force. Then I discussed the problem using max heap or priority queue, you can say, in C++ and Java as well. Then after that, I discussed it using binary search, because we had been given that every row, the matrix is sorted in a row wise and column wise manner, right? This is what I did. Please like the video. I can see a lot of people are live. Please write +1 in the comments so that I know that everything is clear, crystal clear, okay? And all those who have not liked the video, please like the video, because I think that everyone is clear with all the 3 approaches. So please like the video so that I know that everything is crystal clear to all of you, right? Do you have any doubts? Anyone has any doubts up till now? Does anyone have any doubts up till now? Okay, so I'll just wait for 1 more minute. In case if you have any doubt, please mention that in the comments. If you do not have any doubt, please write a +1. Okay, if you do not have any doubt, please write a +1 so that before ending the stream, I know that no one is having any doubt. So after this stream is over, if in case if there is anyone who has got any doubt, so please mention that in the comment and I'll reply back to your doubt as soon as possible. There were 3 approaches for this problem. First one was brute force, then second one was using max heap, then the third way that we could approach it was using binary search. Okay, so this is the problem of the day. That was for yesterday. You can keep on solving the problem of the days. If you like the explanation part, please do consider to subscribe the channel, okay? And we'll bring more such quality content for all of you. Thanks a lot everyone for watching. I'll just wait for 30 seconds more for others to give a +1 in the end. Okay. Yeah, for the third approach, the time complexity will be this, right? The time complexity will be it will be what? It will be order of max minus min, because this is for the number of times your binary search will be running. Then order of n, because you are checking for all rows, and in every row you are taking log n time complexity to find the number of elements which are smaller than the current mid. Okay, so this is the time complexity for the binary search approach, right? Gopi, I hope that is clear to you. So now I think that everything is clear to all of you. So make sure to like the video, hit the subscribe button and the bell icon as well. So thanks a lot everyone for watching, and in case if you have any doubt, so please consider to ask your doubt in the comments and I'll reply back as soon as possible. So thanks a lot everyone for watching and take care.